Hello everyone, welcome back. I hope you enjoyed lunch. My name is Christine, and with Helen, we're going to be talking about how to code good, and then later on how to design good. So a lot of you may have started working on your projects already, and you're trying to figure out the best way to set up your code and your workspace to work with your team members. And we just wanted to provide some tips to help you with that. Okay, so why code good? Well, if you have the correct developer practices, your code becomes more readable, you save time, you're way easier to work with as a teammate, and you also have less frustration while coding, which is going to be especially important as we head towards the milestone too. And as a developer, it means that coding is more fun, easier to do, and also means more money, which is great. Okay, so first we're going to start talking about some tips that can help you code good. And the first one is code formatting and style. So I don't know if you noticed, but in the workshops, we've been using Prettier, which is what makes our code readable and easier for everyone to see. And we totally recommend it. It makes your code pretty every time you hit save. And but something to keep in mind is that you have to decide as a team whether everyone will use Prettier or not to use it at all. Because if only one person uses it, it leads to terrible merge conflicts that I would like to avoid as much as possible. Okay, something else to consider is maybe try using different tools. One is for Git. If you're feeling about terminal, maybe consider using GitGraph or GitLens, which can make your workflow way easier. And also maybe consider using a different editor. We have WebStorm or IntelliJ and Vim. They do have a lot of different features, so you might have to look into that. And Vim especially has a large learning curve, but it's nice to know that those options are available. Okay, and 3, writing quality code. The best style is the one that your team agrees on. So just don't be a lone wolf walking by yourself, but instead discuss with your team about how to progress forward. And something we've noticed is that when you need bad code for your design to work is often a result of bad design choices. So how do we design well from the start? Well, you may have seen this in the lectures we've done so far, but it's good to outline your React component hierarchy, your Mongoose schemas, and also your API specifications. And this just helps everyone in the team know where is what, so it's a lot easier to work together. And wireframe. You probably already did this for milestone 1, but as you keep adding new features to your applications, please continue to wireframe and update them so you have an idea of how your website flows. Yes, a very wise quote. If you don't have any design, you don't know what you're making. So please, please, please design. Okay, and how can you document your design choices? We've discussed the API documentation and also database schemas, but one important thing to do is the JSON doxing. And it's just really helpful because once you open a file, you know what is there and the prop types that you need to access it. Okay, and then you might be wondering, how can I write an API specification? Well, it's pretty simple. For every API route, you ask if it's a GET or a POST. You ask what parameters it expects. You ask what it changes in the database, how much work it needs to do, what is the return and what data types, and also how it interacts with other routes. And one thing to know is that as you continue working on your projects, you might notice that your API routes often depend on your front-end design, which is why it's really helpful to work on your front-end design first. Okay, well, now we want to introduce a scenario. Let's say you wanted to add a new feature, but your code is structured in a way that it's difficult. Would you, 1, refactor your code, which might take 3 hours, or 2, come up with a hacky solution, which takes only 30 minutes? If you would choose 1, can you raise 1 finger? But if you would choose 2, raise 2 fingers. And no judgment, of course. Okay, I see a lot of 2s, and I completely understand. But there's one thing to keep in mind, and you need to be wary of hacky code. What is hacky code? Well, 1, it's super inefficient, it's intuitive to implement, so it might be difficult to go back and revise, and it might easily break if you tweak it in the future. or it messes the library in a way that wasn't intended. So basically all bad things. But if you design well from the start, as we've discussed, with your Mongoose schema, your component hierarchy, your API specifications, you'll be able to avoid hacks at all, and everything will be fine. It's also really important to plan and discuss changes with your team before, during, and after implementation, since implementation is often a continuous cycle and you need feedback from your teammates. So we've talked about hacky code. What is clean code? Well, one principle to keep in mind is dry, also known as do not repeat yourself. So if you notice that you have to copy or paste code anywhere, that is a very bad sign. What you want to do is probably abstract into a function. And you also learn a lot more about this principle in 6031, or which is now called 61020. And then something else to keep in mind is functions. So functions should only do one thing and one thing well. So what you want to do is make sure you define your specifications clearly, what inputs it takes, and what the function returns, and make it as simple as possible. Another thing to avoid is magic numbers, which are numbers that just appear out of nowhere and have no meaning. You can see that example where we've defined length, width, but for area, we multiply length by width by 60. What is 60? We don't know. Only the writer of this code knows what 60 actually is. So to avoid magic numbers, it's useful to have meaningful and accurate variable names, especially because they contain in the future, and just so your code is more readable. So another thing to keep in mind are what are good variable names? Well, good variable names correctly describe what the variable does. So let's say you need to describe how many doors a room has. We could, just have a regular variable name called doors, but this isn't descriptive enough. We can do better. How about number of doors in room? Doesn't that sound way better? Thumbs up with you. Yes, I agree too. So good variable names help readability and remove the need to comment your code. And you always want to make sure to declare your variables in the lowest scope they're needed and avoid global variables completely. This is because you might end up modifying your variables somewhere else and it gets really confusing. And later on when you come back and you realize it's not working at all. And you always want to use const unless necessary. This is when you have to change something, because when you keep something constant, you know it won't change and you're able to avoid a lot of bugs. And you also want to agree on a naming convention with your team, just so everything looks consistent. Okay, so what are some signs that you're heading towards a very, very wrong path with your code? Well, we call this code smell. And as we said before, it's when you have a lot of copy pasted code, you have functions that are really long, which is a sign they're doing more than they should. You also have dead code, which is functions or files that are unused, and it's just generally difficult to understand and work with. So we have this as an example. It's very dramatic, but as you can guess, please don't do this. And if you do come to office hours with code like this, we can't help you. And especially difficult for your teammates to understand what's going on. Okay, and then lastly, we want to talk about technical debt. So we mentioned hacky solutions, and a lot of you admitted that in the pinch of time, you would head towards a hacky solution. So this is important to think about as you're working on your projects. So when might you want a hacky solution? Well, when you don't have enough time, or you're just not in the mood, or you don't know what else to do. And this creates debt that you need to pay off later, which is painful to pay off. And we're gonna work through a scenario. So let's say you're working on your web app, you're starting, everything's wonderful and great in the world. Then you wanna add a new feature, and then you add it. But then it's not quite right, so you sort of add a hacky fix. And it kind of works. So you add another feature, and more hacks, and more features. And you notice that as you do this, your technical debt is rising. Yes, yes. And then it gets to a point where it's so bad, you can't make any progress. And at this point, you probably even see bugs introduced, and you don't even know what's causing it. So you have to refactor. Yes, and refactoring after writing tons and tons of code is very painful, so it's best to just avoid it at the beginning. And this is especially important for products that need to be maintained, since a lot of other people will also see the code later on, and especially if it has a very long lifespan. But with your project, it might not matter as much since it's kind of a hackathon. It's like 2 weeks. But it's still good to know with like future projects, and especially if you're working in a large team. Then comments. So if you see this user endpoint, we have the one on the left and one on the right. Which one do you prefer? If you prefer the one on the left, can you raise one finger? And if you prefer the one on the right, can you raise two fingers? Which one do you prefer? Oh, I'm seeing very mixed reactions. Well, it might surprise you, but I actually like this one. You might be wondering why. Well, if you look a lot closer at the comments on the left, it's sort of describing what it does instead of, which is just taking up unnecessary space. It just makes it really hard to read. So comments are for explaining why you coded something and also a brief explanation of what it does, but not how you did it. And sometimes comments aren't even needed. Sometimes just a well-named variable or function is sufficient. And we have some examples. So for example, load message history, have a clear idea of what it does, or add messages, or set active user. And you don't need comments because you can already predict what it's going to do. Does anyone have any questions? Mhm. Wait, can you say that again? Sorry. Yes, yes, exactly. So one thing to keep in mind that these are just tips. So it really depends on what you're working on and how you find your team works best. But these are just general principles that are definitely flexible. So on to you, Helen.
Okay, so yeah, you learned about some general tips on how to code good. And let's talk about Git hygiene or how to remain on good terms with your teammates. So as always, before you start working, you want to make sure you git pull so that you can load your teammates' changes. And this can help prevent merge conflicts later on that might be difficult to resolve. And also before you commit, you want to probably run, well, before running your git add and git commit commands, you probably want to run git status. And this is because you want to take a look at everything that you've actually changed in order to prevent staging and committing maybe unintentional changes. Let's say that like maybe you accidentally like deleted something in a file that you really shouldn't have, then you should go through your git status or git diff just to make sure that everything you're staging and committing are things that you intended to do. And yeah, you can always review things with git diff as well. Okay, another thing that you should do before you commit is actually build your code and make sure it actually works. Because committing broken code is generally not a good idea unless you're like on your own branch and completely no one else is working on it. Because you can imagine a situation where you push broken code and then your teammate pulls the broken code and now their version of the web app is broken and now they're mad at you. So make sure you test your code before pushing it and having your teammates look at it. Okay, so when do you actually want to commit? When you add something and it works, then you should commit. Committing more often is generally better than less often. So whenever you add like a small feature, it's generally a good idea to commit and keep your commits as focused and clear as possible. So it's like very clear to other teammates looking at your code what exactly this commit implements. You want to avoid mega commits that try to do way too much, such as the commit down here that's fixing styling, removing a bunch of things and updating things, because then your commit loses a bunch of clarity. And it's a lot easier to introduce bugs this way in your commit. So like a teammate who reviews your commit, they'll have a less focused view on what this commit's supposed to do, so they might not catch certain bugs or errors that you may have introduced into the code base. And here are some dangerous git commands that you should really try to avoid doing. The first one is git add dot. Basically, this will add all the files in your current directory to git. So this is going to stage every file in your current directory that you've modified. And again, you might end up unintentionally staging and committing things that you didn't mean to. such as like your node modules file or credentials, or maybe you were working on a file that you're not done with, and then you end up accidentally staging and committing that and breaking your web app. So try to avoid doing this if you can, unless you're really, really sure you want to commit everything in your current directory. Um, and you want to make sure you set up your .git ignore files if you haven't done this already. Basically, a .git ignore file will list all the files in your repository that you want Git to ignore. So anything in your Git ignore won't show up on your remote repository. It will just be on your local machine, and it won't be tracked by Git history. Okay, another command that you really want to avoid is git push force. And you basically never want to do this unless you really know what you're doing. Basically, git push force will replace what's on the remote repository with a copy of what's on your local repository. So you might end up accidentally rewriting your repository and erasing your teammates' changes, and they would be really mad at you, so don't do that. Another thing that you want to avoid is git reset hard. Try to avoid doing this unless you really want to remove everything that you're currently working on that's uncommitted, because this will delete all your uncommitted changes and you might lose all your hard work. Another thing that you generally want to avoid is git commit amend. This amends commits that you've already pushed, and things can get kind of wonky when you rewrite history because maybe one of your teammates was building a feature based on your previous commit, and if you amend that commit, then things just get kind of wonky. So try to avoid doing this and instead just make a new commit with your new changes. Okay, so a lot of you probably know this, but if you use VS Code, which is a very standard editor, on the left-hand side, I put a red box here. If you open your VS Code now, you'll see this. But basically, this is for source control. And if you click on this, VS Code will show you all your staged and committed changes, as well as any files that you've modified already. So in this case, in the example on the right, we don't have any staged or committed changes yet, but we do have a file that was changed. So if you click on the change files, then it'll show you a diff of exactly what you modified in that file. So this is really helpful. I almost always check this before I stage and commit, just to make sure that everything I'm staging and committing, I actually mean to stage and commit. So try your best to check this tab before you commit. It will save you a lot of headaches if you accidentally commit something. Okay, so let's talk about branches in Git. So you should create a Git branch for every new feature that you make that's separate from your main branch. And this is because your main branch in GitHub should really try to be like a clean working version of your code. So if you want to like try a cool new feature for your app and you don't want to mess with like the clean working version of your code, then you should definitely make a new branch. And this is also really helpful if all your teammates are working on different features, then you should all be on different branches, because this will help avoid a lot of possible conflicts if you're all trying to add new features to the main branch. So once you're done with the feature on your branch, you then need to make a pull request to actually merge what's on your feature branch into the main branch. So what is a pull request? Well, a pull request is just a request that someone makes for the owner of a branch, so like for example, the main branch, to pull the changes from one branch to another. And very often you'll be doing a pull request to merge what's in your feature branch into your main branch. And yeah, it's used to sync changes from one branch to another. And you might also run into merge conflicts when you try to merge your branches together. And I'll go over how to resolve those merge conflicts in just a few slides. So typically when I make pull requests, I just do this on the GitHub website because I don't know, it's like easier to me than just doing it in terminal because sometimes I like to write a lot for my pull requests. But if you go to your repository on GitHub, then there's a pull request tab at the very top up here that I highlighted with the red box. So if you click on that, you'll see a list of all your pull requests. And then you can click new pull request if you want to merge a branch. So once you click new pull request, you'll see a screen that looks like this. And then you want to select the base branch and the comparison branch. So the base branch for your purposes is likely going to be your main branch. And then your compare branch is going to be your feature branch that you want to add to your main branch. And once you select these, you then need to write a description for your pull request. And how descriptive your pull request is really dependent on like the company you work at and like also what your teammates want. But in my experience, typically for your pull request, at least at the you should summarize what exactly the feature that you're adding from your branch to the main branch is, and at least describe um, approximately what you did to implement this feature and what the purpose of this feature is. And once you describe that, you can add reviewers because like we're on a pretty short timeline. Maybe you and your team don't want to like review pull requests, which is totally fine. But in industry, you almost will always need someone to review your code, like at least one or two other engineers to review your code before it goes into the main or production branch. But if you want to add reviewers, then you can go to the right panel over here and just press request, and then they'll get an email saying you asked them to review your pull request. Oh, and another small thing is if you're asking people to review your pull request, try to keep them relatively small, like under 1,000 lines. I've had someone ask me to review a 10,000 line pull request, and that was not fun. So try to also keep them relatively contained. Okay. And another thing you might have noticed is that there's a red message here that says we can't automatically merge. And this is because the branch has conflicts, meaning that your feature branch has a conflict with the main branch, and you have to resolve this. You can resolve this in your terminal, but you can also just do it directly on the GitHub website. So if you click Resolve Conflicts, it'll show you all the files that have conflicts and the conflicts themselves. So in this example, we have a conflict between main and W10 step 5. And so it shows us what the code is in main. So in this section is the code in main, and as well as the code in our feature branch. So in main, we have 3 div lines that are not in our feature branch. And so then here you can decide like whether or not you want to keep the code in the main branch or keep the code in your feature branch or keep both of them. And here we decided to keep the code in the main branch. And what you can basically do is just delete everything that's not the code you want to keep. All right, so after you resolve your merge conflicts, you can close the pull request, and then you have the option of just deleting your feature branch, which generally you should do so you don't have way too many branches. And also you're done with the feature, so you can just delete the branch. And yeah, that's basically it. Congrats, you've successfully merged your changes onto the main branch, and now the main branch will have your feature. And if you want more on Git for collaboration with teammates, then you can check out Abby and Tony's lecture here. All right, so that's Git hygiene. Any questions on that? All right, so next let's talk about another important facet of being a developer, which is testing your code. So if you don't test your code, it will eventually break. And this is a very obvious principle because if you don't check that your code actually works, even if you really think that it works logically, you've probably introduced a bug at some point. So you should test as frequently as possible. So in the classes you've probably taken so far at MIT, basically the test cases are written for you unless you've taken 6031. But in the real world and industry, you're going to have to write your own test cases most of the time. So writing test cases is really good practice. And I highly recommend you write some test cases at least. So there's a few forms of writing test cases. The most basic form of testing in web development is UI testing. This testing, you can do it manually. There's also ways to automate UI testing. But basically, UI testing, an example is like if you want to test that a button works on your website, then you just build your web app, navigate to it on localhost, and then just manually check that the button works. We also have automated test cases like unit tests, where you check individual components of your code, such as specific functions or classes to make sure that they work. And we also have integration tests, which is how we test that components of your code interact with each other and work. There's also regression tests. This is just to make sure that as you add more and more features to your web app, the behavior stays as you expected before. So basically this means that your expected behavior stays the same even after you add new features. And a complete testing suite should have all of these test cases. It's okay if you don't have too much time to write test cases for this competition, but generally you should be doing UI tests at the very least to make sure after every feature that you've done, it actually works in the UI and it doesn't break anything else. And there's a JavaScript testing tool called Just. Here's just a link to it if you want to check it out, and this will help you write like automated test cases if you want to do that. I also just recommend at least writing some unit tests for, especially for functions in your code base that might be kind of complicated, just in case uh, like so you can make sure that your functions are actually working and new features that you add aren't breaking previous features you added. And you can read more on testing at the 6031 website. If you take this class, you will do a lot of writing test cases. But if you haven't taken it yet, I recommend like just reading up on this. They go over like a little bit more of a technical view on how to do testing in terms of like coverage of test cases. Basically, coverage means that like the percentage of lines in your code base that your test cases test for. So generally, we aim to have 100% coverage if possible, which means that like your test cases are able to test every line of code in your code base. But that's not always possible. Okay, so once you've written your test cases and you run your test cases, you probably are going to run into errors. And to tackle errors, we're going to need to do some debugging. So a joke in the industry is that 6 hours of debugging can save you 5 minutes of reading documentation. Basically, a lot of developers, including me sometimes, do not really want to read documentation because sometimes documentation is very poorly written and it's just like a lot of giant blocks of text. But you should really try to read documentation. It can save you a lot of debugging hours. Yeah, basically you can think of your web app as a stream of information. And to find out where your bug is coming from, you'll need to look into the stream of information. So recall we have our database in the backend, and we also have our server code, which maybe processes this data in our database. We also have APIs and front-end React code. So the front-end React code will make HTTP requests to API endpoints, which will then harness the server to get the data from the database. So we have our server side or backend code and our client side or front end code. And when you run into an error while debugging your web app, it's going to be either from the server side backend or client side front end. And that's one of the first things you want to figure out. Is this a server side backend bug or a client side front end bug? So some things you should check are the browser console. So if you see an error when you open up the browser console, when you open your web app in your browser, of course, using F12, this means that there's likely an issue with your front-end React code. If you see an error in your npm start or npm run hot loader, so like if an error pops up in your terminal when you run these commands, then it's also likely to be a backend or server side issue. So just make sure you check your browser console and terminal logs. Oh, and another thing is like sometimes you might have bugs that aren't explicitly going to be error messages, and it's just that your code is behaving in ways you don't expect. So that's also a very good possibility, but this is just a general rule of thumb, like you should definitely check for error messages first in your browser console and terminal. Okay, so finally we want you to fail fast. Basically what this means is that you want to detect bugs as early as possible. And to detect bugs as early as possible, you need to be consistently testing your code. And this means that we want you to incrementally test. Every time you add like a new feature or a new complicated function, you should probably test it before you move on to the next part of your feature. So you never want to be in the situation where you finish writing like 500 lines of code, you open up your localhost in your browser to test your code, and nothing works and everything's crashing. And you're going to have to go through like your 500 lines of code then to figure out what went wrong. And that's going to be a big headache. So instead, if you just write like small amounts of code contributing to your feature, like maybe 50 to 100 lines, and then test it to make sure that nothing's crashing, then you could save yourself a lot of headaches. Okay, so here's a debugging checklist that you should think about following. So when you have a bug and your website doesn't work as intended, maybe it's crashing, maybe it's not doing what you want, here's a list of things you should do. First, check your browser console and see if there are any errors there. Read any error messages. Check your terminal running npm hotloader. Check your terminal running npm start. First, just check for any error messages that might be the cause. And then this might seem super obvious, but I feel like a lot of people still forget to do this sometimes. But just Google any error messages that you find in your terminal or browser console. It's just really easy to copy and paste the error and like see what other people like. It's very likely that someone else has had this error before. So you can probably debug a lot of your errors just by looking at Stack Overflow posts. But if you can't find anything on Google, then you should ask your team for help. Maybe someone on your team has had this error before and can help you out. And then you should ask staff for help. It's likely that the staff has also encountered similar errors before, so you should try asking the staff after you've asked your team and asked Google. And finally, if neither the staff or team or Google has seen this error before, then it's going to be rough, but we will try our best to help you. Okay, so a general principle is that the more lines of code you write equals the more lines of code you have to debug. So this is kind of repetitive, but we really want to iterate that you should test incrementally. You don't want to test only after you've written like 2,000 lines of code. Try to write small features that you can test easily, and so that you know they work, such that like you know exactly what you added that caused the error. And hopefully it's just going to be like 100 lines that you have to go through to see what's wrong. Okay, so even if your code seems to work, there's still likely to be bugs. So maybe you don't have errors, and maybe it works in the ways that you expect it to. But it's very likely that users of your app are going to use it in ways that like you would never expect them to. So all your team members, get your friends to do this too. You should try your site and really try to break it. Um, we had these things called bug bashes at Google where we would like gather a lot of people on the team and have them all try to break the feature we were working on. And sometimes we would get like 30 to 50 new bugs reported that we would have to fix, but it's good. The more bugs you catch this way, the less likely users who use your app are going to encounter these bugs once you fix them. And as always, a stable, simple website beats a buggy, complex website. Even if you have like the coolest concept ever for a website, if it's really buggy for a user to use, then no one's gonna wanna use it. Okay, so an overall summary on how to code good. Number one, Git responsibly so that your teammates don't hate you. Number two, limit the amount of hacky code that you have. And three, write code that doesn't need a lot of comments. Basically, like, we're not saying don't write comments because sometimes comments are necessary, but try to write your code, name your variables, and name your functions in ways that they're more self-explanatory, such that you don't need too many comments. Four, develop with a tight debug loop. This just means like, again, try to write small features and debug them before moving on to the next part of your feature. Five, slow down and fix your bugs. And yeah, this just kind of says the same thing as four, where again, try to write smaller versions of your feature and fix the bugs before you move on to the larger parts of your feature. And this is because you don't want your bugs to sort of snowball and pile up on each other and become like a real headache to fix. And finally, communicate with your team. And yeah, that's about it. So we're gonna move to how to design good after this, and just take like a quick 1-minute stretch break. Okay.
Give them more time since we have like a lot of time.
I feel like this is not that long. Okay. Is this small?
Okay, so we talked about how to code good, and now we're going to talk about how to design good. Okay, so you may have noticed looking at Piazza that there's a post Joyce left that in WebLab, not only looking at functionality, which is a really cool feature you're hoping to implement with your project, but we also care about the user experience and usability and also how it looks like, which is why the user experience and the user interface are important. And you may already seen some of these concepts mentioned in the design lecture, but we just wanted to repeat it for emphasis. Okay, so there's a lot of information about there. It's like a rabbit hole, but we're just gonna outline a few principles that you can keep in mind. Okay, one is aesthetics. So the font and formatting can give a different vibe, and you wanna make sure you pick one that works for your use case. And these are just examples about how, depending on the font, the vibe you're giving can change. Something else you want to think about is visuals. If you look a lot closer to the image on the right, you notice although the color palette and the layout is kind of the same, the images really help carry the message that the site is trying to promote. Something else to think about is audio. So these are some examples of websites that give free sound effects that you can use in your applications, such as Soundstripe, Pixabay, Epidemic Sound. And there are also a lot more resources available just to give your project an edge. And something to think about is styling and theming. How do all these concepts we talked about, font, visuals, colors, how do they all come together to work for your project? Well, you want to think about whether you have a consistent theme and whether it fits with your idea. We're just going to look at some examples. So the first example is noisy. If you look a lot closer, you see like glitch, you see a lot of like neon bright colors, and it just gives like a punk, edgy vibe. It sounds like I'm describing an art piece, but I hope you get the vibe I'm trying to explain. Um, then the next example is this website. It's very pink, very rounded, very cute, and it just has a really different vibe from the previous one. Okay, and then something you also want to think about is website flow and how this works for your purpose. So for example, on Facebook, we have and a lot of websites, we have the infinite scrolling feed, which is front and center on the website. And the reason why it's so great is because you continuously scroll, you're able to keep the user's attention for a very long time. And then we have the example of Wikipedia's main screen, where the search bar is the first thing you see, especially since it's a website design for finding information. And you also see how it promotes the amount of languages it has, which is another cool feature about Wikipedia. Okay, then you also want to think about intuitive use and control, which is a key part of the user experience. So do buttons make sense? Is it obvious to click them? Is this way I want to try and make the user input data the best way it can be? And then we just wanted to put this really bad example for kicks. I think it's really funny, but I have a bad sense of humor. But please don't do this. There are definitely better ways to input this information. Okay, and something else you want to think about is responsiveness. So do users feel like they're in control of the website? An example is styling hover and click, which is available on Safari. So if you notice that if you hover over a tab, you're able to see like a preview of what that tab contains. And it just feels like helps the user feel like they have a lot more control over the website. Okay, and especially since we've been working with asynchronous functions, one thing to keep in mind is to avoid the circle of doom, which is just like this continuous loop that just keeps on running, and it can make your users feel very discouraged. So make sure that other things that you need to get done are happening while your callback function, before your callback functions are fulfilled. So that's just one thing to keep in mind. Okay, now on to Helen, who will discuss handling edge
Oh,
cases.
yes. Okay, so we talked about earlier in this lecture how you want to handle like users doing weird things on your website that you would never expect. This is kind of a similar idea. Sorry. where you just want to handle a lot of possible things that could go wrong when a user is using your site. So one thing that you might want to consider is bad internet connection. So what happens when a user is lagging because of bad internet connection, or what if they suddenly disconnect? Are you going to save their progress before then, or will a user lose all their progress? So like if you're implementing maybe like a note-taking app or like a game, and like maybe the user has spent a long time playing the game to get to where they are, and suddenly they disconnect, that would really suck if they lost all their all their progress. So you might want to think about how you're saving user progress in case they have internet issues. What if the user decides to close the tab randomly or they accidentally close their window? Does your progress save? Does it break? This is kind of similar to the previous thing you might want to consider. Again, your user might do weird things and you just need to account for this. What happens if the user opens web pages that should only be accessed in certain ways? So let's say that you design your web app such that the user starts on the home page, then they click a button and navigate and get routed to the other page, and then they get routed to another page. What if instead the user directly types into the URL and routes them to the last page in the sequence? And is your web app going to basically break at that point? You probably don't want that, and you want to consider cases where the user accesses pages that you might not want them to at a certain point. Okay, and what happens if the user leaves their tab open too long and it logs them out? So like, what if the user fell asleep while playing your game? And you might want to account for this. Do you want to save their progress? And at what point during an activity do you want to save their progress and log them out? What if the user opened multiple tabs of the same page? What if the user opens your site and opens 10 duplicate copies of your site? If you're writing a game, is that going to spawn 10 different players? And which tab is going to have its progress saved? So just a lot of things you want to consider. Like, this is a really weird case, like why would a user do this? But someone might, so you might want to consider what would happen. And yeah, there's basically a lot to consider. Again, when you have a large user base, like users do a lot of unexpected things, and you just want to try really hard to break your app in these ways and make sure that you handle these edge cases. All right, so the next thing is lag and optimization, which is especially useful to consider if you're using any like real-time messaging or if you have a multiplayer game or something like that. So it would really suck if you had a messaging system or a video calling system or a game where the ping is that many milliseconds. So we definitely want to try to reduce lag as much as possible because I'm sure you've played games with a lot of lag and it just really isn't that fun. So how do we fix lag? One thing you can do is try to minimize the amount of unnecessary and repetitive computations. So you can go through your code base and really try to examine if there's anything you're doing repetitively that you don't need to do. A common mistake is to have a for loop running where you're doing like a lot of repetitive work in the for loop that you don't need to do. So let's say that you're calculating like the volume of some static cylinder every time in the for loop, and you do this 10,000 times in the for loop. And that's a lot of repetitive work. So you can move that then out of the for loop and reduce the amount of work being done by a lot. So just take a look at your code and see if there's anything unnecessary and repetitive being done. Another thing you can do is bundle communication into packages. So it takes time to communicate with the internet because a lot of times maybe the server is very far away or there's just some sort of lag going on that's out of your control. So one thing you can try to do is instead of contacting like the server multiple times with sending over information or requesting information, you can bundle all of that communication into just one step. And that might help reduce the amount of lag. Okay, and the client should do as much as it can without server communication, again, because server communication, sometimes it's unreliable and can be pretty slow. Okay, next up, the general feel of your app. And you might have gone to websites or played games that just felt really satisfying. And that's like a pretty big draw for some people, like games that just feel nice to play or websites that just feel nice to look at. And what contributes to this? Well, there's a lot of there's a lot into it, but some things that you could consider adding are animations, particle effects, screen shake, vivid colors, and so on. So here's a nice example of some particles and vivid colors, and it's just really nice to look at. So, if you added something like this, um, it's just, it's aesthetic and it's fun to look at. There's also animations that you can add. For example, this bouncing Pusheen, it's only 3 frames, so not that much extra work on animating, but it does add like quite a bit to this page, and it does make it seem a little bit more dynamic. You can also consider adding sound or music to your website. Sound, you can use sound effects. So like if a user clicks a button or achieves something on your site, maybe you can play some sort of sound effect. And even though that's like a really small addition, it does make your website seem a little bit more alive. You can also add music. I'm sure you've all played like games or gone to websites with like a nice soundtrack or background music. So that's something that you can also consider adding. Another thing is fluid or natural movement, and this is mainly applicable if you have some sort of like game or I don't know, some sort of movement involved in your website. Basically, you might have played games where like maybe the movement is really laggy or jagged. Um, then it's just not as fun to play as a game that has like very smooth animations. So adding fluid or natural movement is actually a bit out of the scope of this lecture, and it does involve quite a bit of physics. So if you're interested in how you can smooth out animation for games, then you can talk to us after lecture, on Piazza, or in office hours. Yeah, a final remark is it's easier to enjoy the idea of your site when the implementation is good. Like even if you have like the best idea ever, if your website is laggy or buggy, then it's just not going to be great. So do take a lot of time to consider the design behind your website and take a lot of time to make sure that it has as few bugs as possible. And finally, have fun. Yeah, that's it. Does anyone have any questions? All right.